functional goodness in there as well. Before we go, while we have a hive mind here of interesting and like-minded individuals, what are you stuck on? What can we help with?
Anyone know?
Not to worry. If you find things afterwards, let's definitely dive into all the things. Cameron, I'm really excited about this presentation. Are you ready?
This really isn't ever going to be Rob. I appreciate that. Like Barry's like, I got something. You're like, nah, man, we ain't doing that. This ain't time. This ain't gonna happen.
I'm sorry, Barry. What do you?
No. Let's get started. Cameron, please, to you.
Wonderful. I'll go ahead and share my screen then, and then I'll let people start hitting the buttons that need to be hit. All right. If everything has worked correctly, you should be seeing a PowerPoint presentation.
Yep, we can see it.
Wonderful. All right. So let's go ahead and get started then. So good evening, everyone. My name is Cameron Presley, and tonight we'll be taking a look on how to level up your functional programming skills by rebuilding LINQ itself. Don't really have a whole lot of assumptions of the audience, except for the fact that you can read code of some language, and we'll go from there. Throughout the presentation, feel free to ask questions in the chat. I'll do natural pauses, and I'll reach out to either Barry or Justin or Rob to kind of ask those questions. We'll get those answered. So first things first, the big thing I want to make sure you're all aware of, there are no need to take any notes. Everything you're going to see tonight is already live in existence. You could technically just grab this slide deck and run away, but I really hope you don't, because some of the slides may not make sense to you. So you've got one of two ways you can get access to it. If you've got your smartphone handy or you want to take a screenshot, you can literally scan this QR code and see what's going on. If you are more of a URL, I'll make sure that this info gets shared to the right people, but you can always go to my blog, go into presentations, and you'll find the slide deck, code examples, resources, books, everything. So like I said, no need to really take any notes unless you're just so inclined. Sound good? Wonderful. Yeah, I do a lot of audience interaction. So if that's not a thing for you, that's okay, but it's going to be a really long evening, because I also have bad jokes. And if you don't like the bad jokes, they're going to evolve to dad jokes, because I've got a 2-year-old, so I'm totally qualified to be dropping them. If the Arduino's into Raspberry Pis didn't give you a forewarning. So a little bit about myself. Like I said before, my name is Cameron Presley. I am a lead software engineer for a company called Century One, based out of Charlotte, North Carolina. How many of y'all have ever had to deal with SQL Server? I imagine, yeah. How many of y'all have ever asked the question, oh goodness, why is this query so slow? Oh goodness, why is SQL Server doing this thing I'm not expecting it to do? If you've ever asked yourself that question, we probably have a product to help you out. One product that you can go ahead and try out today is Plan Explorer, which will kind of help you, give you some hints and tips and tricks on how to make your query a lot more efficient, especially if you're having to troubleshoot some interesting Entity Framework behavior for some strange, odd reason. Microsoft MVP, which all that means is I like doing stuff with the community. I'm not a technical expert. I do not know LINQ like the back of my hand. I do not know all of .NET like the back of my hand. All this means is I learn stuff and try to teach it to others to help level up the community. I'm the director of speaker relations for CodeSock, a little tech conference based out of Knoxville, Tennessee. So a little bit interesting there. And I run a functional programming user group called Functional Knox. So if you haven't picked up on that yet, functional programming is kind of the thing for me. And that kind of sets the stage for what we'll be covering tonight. So let's go ahead and look into it. So this evening's presentation is really going to be over 3 parts. The first part is we're going to talk about what is LINQ. We're going to start that I assume nobody on this call knows anything about it, and build up from there. Once we kind of know what LINQ is, we're going to take a look at 3 fundamental concepts that, with the addition of these concepts into .NET, you can actually write LINQ yourself. You could have invented LINQ, and we're going to look at that tonight. And as part of inventing LINQ, we're going to actually implement our own versions of map, keep, and reduce. So for those of you who are more LINQ aficionados, you'll know this as select, where, and aggregate. But I imagine one or more people sling Python or JavaScript/TypeScript, so these terminology may resound a little bit more. Sound good so far? Wonderful. Slides are already in existence. I can't really make a whole lot of changes on the fly right now. So let's take a look at LINQ. And we're going to be going through this kind of code example. And so let's start with, we've got this C# class called a delivery team. So if you've got a delivery team, team's got a name, it's got someone who's the lead of that team, and it's got a number of teammates, right? So imagine that this is a featured delivery team at your company that you work at. So we might have some code that looks something like this, right? We've got a whole list of delivery teams. So we've got like alpha team, back to the code, skill overflow exception, and getting things done. And so you find yourself wanting to find some information out about these teams. So maybe the coding task that you've been assigned is you need to determine which delivery teams have more than 7 members. So without using LINQ and maybe a fundamental approach or a very basic approach, you might write code that looks something like this, where you've got a list of 2 large team names. You go through the list of teams originally, you check to see if the member count's greater than 7. If so, you add it to the list, and then you return this list. Pretty straightforward, pretty elementary approach. One thing though that's kind of annoying about this is, can anyone tell me the code that you actually cared about? How much of this was actually business rules versus boilerplate? Feel free to shout it out or put in the chat, either or is good. Wonderful, stunned silence. Those 2 pieces.
Greater than 7.
Yeah, so those are the 2 pieces that you actually cared about, right? Was the team.member count greater than 7 and then the team name. The rest of this code is totally boilerplate. Wouldn't it be nice if you didn't have to write all of that? Well, leveraging a little bit of LINQ, we could accomplish the exact same effect by writing the following. Teams.where, and we're going to say, hey, I want all the teams where the member count's greater than 7. And then now that I've got that team, I just want to grab the name. What's really nice about this approach is A, it's less code to have written, but it also puts front and foremost what the business rules were, right? The part that we actually cared about. Pretty nifty. So you've seen an example of LINQ, but what is LINQ, right? Like what's so cool about it? So LINQ at a high level is a set of operations that work on data that's independent of the source. And this to me is one of the coolest things about LINQ. It doesn't matter if these objects came from your database, it came from a file system, it came from in memory. It just works. How many times in software can you say something just works, right? The other cool thing about LINQ is that these operations that you have, they're type safe, which means if you mess up on one of the types, the compiler tells you at compile time that, hey, buddy, you messed up. I'm a huge fan of the compiler preventing me from messing up, right? I hate it when it smacks me on the wrist saying you forgot a semicolon. I'd much rather it tell me, hey, man, that code you wrote literally won't work. Literally can't even. It's too odd. So let's keep going a little bit and why I think LINQ's so important. LINQ makes code at this first example that's very boilerplate and very kind of hard to even parse, and something that's a little bit more succinct. And throughout tonight's presentation, you will actually find that by using certain LINQ commands, you get a lot of properties about your software for free that you may never have thought about before. So we'll be diving into that. So LINQ's pretty cool, but what actually makes LINQ work under the hood, right? What are all the components you need to understand? Well, to really understand how LINQ works, there's three pieces. This new data type called Func, and what a Func is. The second concept we're going to cover is generics, and why that's so important, how that can actually dry up the amount of code you have to write. And last but not least, extension methods. This ability to attach methods and functionality to types that you may not own. But first things first, let's get functional with the Func data type. All right, so a little bit of background on the Func data type. This was introduced back in C# 3.0. So for those of you keeping track at home, I believe that was 2007. So it's been around for a minute. What's interesting about the Func data type, though, is unlike strings and integers and booleans that are just values, a Func is a data type that when you invoke it, it actually gives you back a value. It actually gives you something from something. And that's kind of an interesting concept. And the Func data type requires 0 or more parameters to be passed in when you invoke it. This is a whole bunch of technical stuff that is kind of cool, but let's look at this in action, right? Because I want everyone to be able to understand and read the func data signature. So let's say that we had code that looks like this, a func of int. What in the heck does this mean? If you ever see this in code, a way to interpret it is this is something that says, you don't have to give me any input, but I'm always going to return you back an integer. So here's what an example implementation may look like. I've got a function called getNumber, open close parenthesis, and anytime it's called with no parameters, it returns me back 2. Make sense so far, kind of? Cool. Let's make it a little bit more complicated. That's software development, right? We take something simple, we make it a little bit more complicated. So let's take a look at this signature. We have a func of int comma string. So the way to read this signature says, okay, if you give me an integer, I'll give you back a string. So a typical implementation of this may look something like the following, where I write a function called toString, it takes in any parameter called x, and I'm literally just going to call toString on it. There's all sorts of other implementations I could have done here, but just by looking at the signature, I know that I have to give it a number and I'm guaranteed to get a string back. And we can keep making this more and more complicated. Does anybody want to take a guess what the data, the type signature for this func would look like?
X comma Y.
X comma Y. Okay. So can you elaborate a little bit for that, me, Jeremy?
You use an integer and as the first parameter, string as the second parameter. And you return ultimately a string.
Bingo, you got it, yeah. So the way to read func type signatures is all the parameters starting from the left are the inputs, and then whatever the final parameter is the output. So yeah, so here's some really nasty LINQ code you could have done, but you don't have to parse through it, but pretend that if you gave me the number 4 and the word hello, you would get hello, 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 all as one string, right? That's an implementation, but we could have done other things there too. So this is pretty cool, but what if I told you already in this presentation before this slide, you've already seen a couple of funcs running around? Don't believe me? Let's take a look. So everybody remember this code example, right? This is where we go through the list of teams, figure out which teams are a little bit too big and what their names are, right? Well, fun fact, that piece of code right there, that's a func. That's what the .NET compiler is doing for you under the hood. It's actually taking that little anonymous method, a lambda, if you will, and turning it into a func that says, given the delivery team, I'm going to give you back a Boolean value, right? So T was your delivery team, and then that the greater than, right, that's going to give you back a bool whether that's true or not. The second func you've already seen is this one here, where given a delivery team, you get back a string, in this case, the name. So at this point, let's take a moment and Barry, are there any questions in the chat that we need to talk about? Barry, I got you on mute, buddy.
I don't see any questions. I think you're good.
Wonderful. Okay, so let's say though that you wanted to refactor this code a little bit to make it a little bit more explicit that you're using funcs. So a valid refactor you could do could look like the following, where we take that same logic that was in the where clause and the select clause and move it up to their own func data types. This is still valid code. This would still work. This is still doing the exact same thing that you had before. The only difference is that you're being much more explicit that you've got this named function running around. I imagine most people on this phone call do this crazy thing called unit testing though, right? Maybe a little bit. Yeah, I know, Jeremy. Jeremy, I think me and you are best friends here, buddy, because I see like you making the same face I'm doing, like, it depends, don't tell my boss, right? But let's say I wanted to write some unit tests on this. Well, here comes the other cool thing. I could actually turn those funcs, refactor it, and turn them into full-blown methods. So take a look at that, does team have more than 7 members, right? The signature of that method is something that takes in a delivery team and returns back a Boolean. Well, that's what the Func data type is. So the compiler is actually helping you out a little bit and going, oh, hey, you're using a method that has a signature. I will totally coerce that into a func for you under the hood. And just by making this method public, we can easily write unit tests on it, all that type of stuff. And similar thing with get team name, right? It was a function that says, given a delivery team, I'll give you back a string, and doing the same thing here. Making sense so far? Kind of, maybe. No one shouting me off stage, so I'm going to assume we're doing good.
You're doing good.
Wonderful.
So we do have a question for you.
Wonderful. What we got, Justin?
So Tandy just asked, can you pass a func into a func?
Yes. Yes, you can. And in fact, the word you're looking for there is a higher order function. If you're wanting to look for your Googleable phrase of the evening. In fact, when we get into some of the LINQ implementations, you'll see that that's exactly what you're doing is you're passing a func into a func of sorts. Great question. Any other ones?
If people have questions, feel free to unmute yourself and ask.
Oh, too late. Awkward pause has passed. Let's keep going. So at this point, you've learned enough about funcs to get dangerous when it comes to implementing links. So let's go to the second concept. Let's talk about writing more general code using generics. I promise it may be your cup of tea by the end of the evening. So let's take a look at it. So generics have been around for actually a lot longer, I believe since 2005. So once again, this is a pretty old concept. And the cool thing about generics is that it allows you to do this cool thing called type parameters. Cameron, what in the heck does that mean? We'll take a look at that. But what's interesting about it is that you can now define types that can parameterize around another type. And it's really cool for when you write code and it just kind of works for any type. And you're like, Cameron, this is really vague. Can you put some concrete examples? Sure. These are all examples of generics in action. If you've been in .NET for any length of time, you've definitely used the list data type. And you just learned about the func data type. And you know that they're using generics because of these angle brackets. 99% of the time, you're in a code base of C# and you see those angle brackets, the thing that has the angle bracket, so in this case, the list type or the func type, is totally using generics. And let me show you a more real world scenario where generics could actually help you out tremendously. So I'm going to lean a little bit back on some computer science theory, but we've got this class called a queue, a number queue. And it's pretty much what it sounds like. You can add numbers to the queue. You can pop numbers off the queue. We'll even throw an exception if you try to pop something off an empty queue, right? It does all the fun things. But let's say that you've got this number queue in your code base, and you know what? Product owner, your product comes down and says, Cameron, number queues are awesome, but you know what's really in vogue right now? String queues. We're going to need a string queue. And you go, all right, cool. So you write a new class called string queue, and you put all the code in, and then you're a developer, so you're probably really good at pattern recognition and go, wait a minute, man, these classes look similar. Man, these classes look so similar that in fact, maybe the only difference are the types. Oh, snap. Is there a way that we could refactor this so that we don't have to duplicate as much code? Sure. This is where generics come into play. So we can write a new class called Q that takes in some generic called T, and we'll define T at the very top of the class. The minute we define T at the class level, that means we're going to use that same type throughout the rest of this class implementation. So you notice that we've done it at the list level. We notice we've updated constructor. We've updated the add method a little bit. We've even updated pop. Now that we've got this generic implementation running around though, instead of having to do a queue of like a number queue and string queue data type, we can actually leverage the following. We can just say queue of string, hey, do this, queue of int, hey, go do this. That's really powerful. And in fact, before generics were introduced, this is actually how you had to do lists. Like if you want to do list on custom types, you had to write your own that inherited from the list data type. How annoying is that? So a good rule of thumb that when you're working with generics and you don't know whether you need to use them or not is when you find yourself writing that third thing in a row that looks exactly the same. right? Whether that be a function, whether that be a class, whether that be a method, you can use generics on that. The big thing to keep in mind is when the code looks exactly the same, but only the types are a little bit different. And there's more powerful things you can do with generics. You can put constraints on and all that stuff. But that's a little bit outside the scope of tonight's presentation. As long as what we've talked about so far kind of makes sense, you know enough to be dangerous. So let's take a pause at this point. And Rob, do we have any questions in the chat?
Nope, we're good.
Okay.
We've got lots of puns though.
Oh, good.
The cup of tea is a big hit.
Oh, absolutely. Would you say it's high quality?
Oh, that's awesome.
All right, moving on. Let's talk about extension methods then. So extension methods were introduced in C# 3.0 as well. Now, for those of you playing along at home, you just realized that the Func data type in the extension technology came out in the same version of C#. I wonder why. So the interesting thing about extension methods is that they allow you to add new functionality to types without having to recompile or creating new types to work with it. And this is really cool for when you want to add functionality to things that you don't control, right? The classic example, how many people are actually doing ASP.NET MVC, like .NET Core type stuff? You can just like raise your hand in the chat or whatever, right? So that, you know, the new logging framework that Microsoft kind of wants you to use through all that, it uses extension methods under the hood. That's how it works. All the log warning, log debug, those are extension methods. But you could always write your own and extend it. Like it's kind of interesting in that way. But let me show you kind of an example implementation of an extension method so you can understand the coolness and sometimes the scariness of it. So you typically know that you're dealing with an extension class or extension methods when you see the following. You've got some public static class, and it's usually named the type that you're extending followed by extensions. There's nothing in the compiler forcing you to call it this, but it's a good naming convention, and it's going to save the future developer, especially when it's you 3 months down the road. So an extension method always looks something like this, where it's a public static method, returns something, has a method, and then it's got this keyword. That particular keyword is what makes this an extension method. And what's really nifty about doing it in this fashion is the minute I define capitalize on any string in the application, I can call .capitalize. I can do that. I don't own the string type. And in fact, if you take a look at the definition for string, it's a final class. You can't even inherit from it. So that's pretty cool. I can add some functionality. So in this particular case for capitalize, I check the string. If it's null or white space, if it is, I just return you back the string. Otherwise, I'm just going to capitalize the first letter, nothing crazy. But the minute I write this, I can unit test it. I can do all sorts of cool, fun stuff with that. Not too bad. I can also do other crazy things, like creating a new method called crazy case. That's an extension method off string. And what it does is it does alternate casing on the string itself. So every other letter is capitalized, for example, and the opposite letters are lowercase, right? But I can keep doing all this stuff, and I can extend all these types, built-in types, my own custom types, so on and so forth. For those of you who have more of an architecture background and are familiar with the onion architecture, extension methods actually provide a way to give you scoped access to certain functionalities, because you can define your extension methods in a namespace and then make sure that namespace is only used in certain layers. So there's some architectural applications of that as well. But if this somewhat made sense, this idea that you can add functionality to types that you don't own, you could have invented LINQ. If you understand these three concepts even at a rudimentary level, you could have made it yourself. In fact, it's such a well-known thing about the extension methods and connection to LINQ that if you go to the Microsoft docs themselves on extension methods, you will find this quote. The most common extension methods are the LINQ standard query operators that add query functionality to the IEnumerable and IEnumerable T types. And for those of you playing along at home, realize that you just saw bracket T, that may be a generic, which is the other thing we've talked about this evening already. So we've talked about a lot of stuff, right? We've talked about 3 components. It's time for us to get dangerous. It's time for us to start writing some code. So I'm going to pause one more time. Is there any questions in the chat?
We're good. Somebody really likes a QT though.
I rip. So let's write some code now. So here's the way that we're going to approach this. Our design guidelines are going to be of the
Oh,
following.
actually, we just got a question. Apologies.
Oh, yeah, no worries. What's up?
This sounds like a lot like Modus Pone. I'm sorry, I'm slamming your name. Says it sounds a lot like mixins. Is this a flavor of it? If not, what are the key differences between this and mixins?
Oh goodness, so that's a really good question. I'm actually not familiar with mixins, so I can't answer that. I think my understanding of mixins comes from like the CSS world, but that's about as much as my knowledge. Sorry. Anyone, as maybe one of the moderators or someone else can kind of chime in and throw their 2 cents into the arena.
I can chime in there. Mixins are a great way to do aspect-oriented programming. And so extension methods are kind of a good analog for mixins. Part of mixins is a dependency injection framework or a mechanism of knowing to run the mixins before or after, or a mechanism of compiling those in to run before and after. And so this doesn't have any of those parts of the mixins. But what is really cool about mixins is that they run, you can start to extract the common functionality out of your methods into the mixins. And so in that sense, extension methods and mixins serve really, really similar purposes, being able to extract the common pieces out of your code to put them somewhere that you can test them individually and then apply them more globally.
Yeah, that's pretty much, yeah. Awesome. Thanks, Rob. Cool. Any other questions? All right. No one's telling me there's any, so I'm just going to keep the ball rolling.
Yep. No more questions yet.
Cool. All right. So we're going to implement our own version of LINQ. So there's a couple of restrictions we're going to put upon ourselves. The first one is it's going to extend the IEnumerable type. And the reason why we're extending the IEnumerable type is that's because that's how LINQ works under the hood. That's actually what its extension method's off of. It's also going to have the same type signatures of LINQ. So when we implement map, which is our version of select, it's going to take the exact same parameters in and same outputs. And it's also going to have the same properties. Now, my experience is most developers don't think about the various properties of LINQ. And so that's a fun conversation to have. So let's go ahead and go right into map, right? So what is map, what is select in LINQ parlance? So when you're writing select or map, its signature is something of the following, where if you have a collection of one type, you can change it to a collection of another type by using some mapper function. That's really what it's doing. And what's cool about map is that it has this really nice property that it maintains the length of the collection. You're guaranteed that. And what I mean by that is if you call select on a list of 10 items, you're going to get a list of 10 items back. Not 9, not 11, not null. You're guaranteed to get exactly 10 items back, which is a kind of nifty little property to have for select. So let's take a look at how we can refactor this and get to such an implementation. So we've got this delivery team class set up again, right? Name, team lead, member count. You've seen this like 20 million times before. And we've been tasked with the following, right? Given a collection of delivery teams, we want to see the names of the teams. So like a good developer, we write the following code. And we write this little for each loop that goes through the teams, get the team names, right? And you've seen this a couple times now, nothing too terribly crazy. Going back to the previous comment about mixins and kind of their relationship though, let's say that you end up writing this type of code 3, 4, 5, 6 different places. And you're like, well, I don't want this logic in 6 different places in my code base. That's what we like to call a bad thing, right? So how could we put all of this in one spot? Well, we could do a static class type thing and that would kind of work, but static classes are kind of weird. Why don't we extend on the listed delivery teams? So by doing such a thing, we end up with the following code, right? So for those, so from the extension methods lesson, if you will, we have this public static class called delivery team list extensions. And what it's doing is it's extending upon list of delivery teams. So by doing this, anytime I have a list of delivery teams, I can do .get team names and it'll give me back a list of team names. How cool. I've dried up my code a little bit and I've got this running around. Not a bad approach. Here's the problem though. Product comes back to us and says, well, that's kind of cool. We've got the names of the teams now, but we're now curious about to see all the team leads, right? We want to see the different the team leads for all the teams. So we make sure there's not one person the lead of multiple teams, because that would be an overwork issue, right? You don't want somebody managing multiple teams. That could be bad. So you go big brain moment. Instead of having this logic copy pasted everywhere, I'm just going to go ahead and jump straight to an extension method. And I'm going to write the following. And it looks kind of similar, right? Go through the teams. This time we're describing the team lead and returning back the team lead names. So at this point, we've got these two extension methods running around. And man, if we take a look at this code, oof, this looks similar, don't it? Anyone want to take a guess like what the only difference is?
What strings being returned?
Yeah, exactly. What string's being returned, right? So it's actually just this section. So what if we refactor this extension method a little bit so that we can pivot on what string value to return back? That's a great observation there, Mike. So we could write something like the following, where we've got an extension method called getStringValues. So what you'll notice is that it's still extending off the delivery teams, but now we've got this new parameter. This func that knows how to go from delivery team to string, we've called that getter for right now. And then so we can use getter on the for each loop, where we just say .add and then call that function. So when you find yourself wanting to like get a certain piece of information out of a class and do some logic with it, like we did here, refactoring to use a func is actually a pretty solid approach to go with, especially if the logic's really simple. Not bad. So the minute we have the getStringValues extension method in play, we can actually refactor the other two existing ones to look something like the following. So if you recall, we have getTeamNames. So the code that's commented out is what we used to have. Now it's just called teams.getStringValues of team.name. And team lead names looks exactly the same, except now it's team lead. But the thing that's different is the thing that's supposed to be different. What value are we getting out of the off the team, right? It's not copying and pasting this for each loop and all of that. So without doing too much work, we've already dried up a lot of this code. Not bad. Let's go a little bit further. So now, right, you've now realized that product's actually been wanting you to write a report this entire time. They just didn't know it was called a report. So now they ask you like, hey, we want to know the number of the team members on each team. And so you're like, oh, blessed. Okay. And you're like, I've had it. So you write this new extension method called getTeamCount, and it looks very similar. In fact, I imagine you all are like, come on, Cameron, you're hitting us with the same for each loop again. I promise there's payoff here. So we go ahead and do the refactor of getTeamCount into the getInteger, like getInt values. We go ahead and make that refactor. So now we've got getStringValues, getInt values. So we have these two methods. Oh boy, though, take a look at these methods. What do you see is the difference between the two of them? Anybody want to take a guess?
Type.
Yeah, the types. Type. Oh, yeah, exactly. Someone's already said it. Only the types are different. So let's leverage some generics here, shall we? So we do another refactor and we end up with map. So we've got this new thing called map, and it's actually pretty nifty. The only real changes we had to make was instead of a list of string or list of int, we made it of t result. That's how we signify it's a generic, starts with t and it's in the brackets there. And in the values, we say it's a list of t result of values instead of list of int or list string, but otherwise this totally works. In fact, it works so well that if we take a look at get int values and get string values to use map, they're exactly the same. So guess what? Axe it, get rid of it, burn that code. Developers' best days, right? Burning code. So get rid of them. So now if we take a look at our three extension methods, they all look like this: teams.map, team of team name, team of team lead, team.member count. You could make the argument at this point that maybe you don't need those extension methods anymore. Maybe you put them back in their respective spots. Who knows? But you've got the options here, and your business rules are now forefront, right? You're not having to parse through all the loops and such. Let's get a little bit more crazy though. Is there any reason why this should only be able to work on the delivery team? Let's go generics one more time. So the big difference in this version of map is that instead of being keyed on delivery team, we introduce a new generic called T source, and so everywhere we had delivery team, we just replace it with T source. This code still works. In fact, this code works so well that if you were to look at the select implementation from GitHub, Microsoft's own implementation, it looks suspiciously similar. The cool thing about this is, remember that property we talked about before, where if you call map on a list of 10 items, you always get 10 items back? It has to be implemented like this. There's no other way it could be for the type system to check out. You literally couldn't bleep this up because the compiler wouldn't let you. How cool is that? Now, for those a little bit more astute, you're realizing I'm showing you the toList method off here, and you're like, well, Cameron, that's not select. Fun fact, this is actually one of the optimizations that LINQ is doing under the hood for you. Like, so if you were to go look at the Microsoft code, depending on whether you do a toList or something else will actually slightly change how it processes the items, because it can do it a little bit more efficiently if it's list versus an enumerable versus whatever. But for our case, it literally doesn't matter because it's just an optimization. The literal root of how it's doing it is exactly the same. How are we doing so far?
Fantastic.
I've got one question.
Yeah, go for it.
Rob asks, could we yield return instead of creating a list?
Okay, cool. So do we need to limit to lists? Absolutely not. We can totally just get we can totally just use yield return. So thanks, Rob. I appreciate you leading me on in a good way. Good way. Yeah, but so I show you with the list to be a little bit more explicit with Microsoft. But if you do it off the IEnumerable, it's exactly the same code. The only difference is that you do a for each here, and it's the yield return, and it's that yield return that forces it to be an IEnumerable. But yeah, absolutely no reason why it had to be in the list, Rob. Good observation, man. What other questions are there?
That was it.
Wonderful. Yeah, so here comes the cool thing too about extending the IEnumerable type. You can write your own collections that implement IEnumerable. And the minute you write your own collection that implements the IEnumerable interface, you get LINQ for free. Neat. So at a high level, you're going to use map to transform the collection from one data type into the data that you need, whether it's just getting a property off of it or switching its type around entirely. But that's what you're going to use it for. So with select/map down, let's go one further. Let's keep going with the T, if you will, tea or coffee here. Keeping what's needed with keep. I've never been a huge fan of some of the naming terminology for LINQ because like no one calls it select. If you go to any functional community, it's known as like map. However, this is one of the spots where I think Microsoft actually did a good job keeping it where. Because in a lot of languages, it's known as filter, and you can never remember to filter it in or filter it out. But with where, it's pretty straightforward. So in this case, we're going to call it keep because that's what we're keeping. So the cool thing about this method is given a collection, it's going to give you a subset of it based on some predicate. Now, for those of you who've been in .NET for a long time, the word predicate may be ringing a couple of bells of like, oh, that's an actual data type. But for those of you not familiar with it, you can think of it as a func that goes from something to Boolean, essentially what a predicate is. So keep and or where actually have a lot of interesting properties. Here's a couple of them. You're guaranteed that whatever collection it gives you back is somewhere between 1 and the original length. So if you call keep on a list of 10 things, you're not getting 11 back. You're getting somewhere between 0 and 10. The other cool thing about it is you don't get items that weren't in the list originally. So it's not like if you had the numbers 1 through 10, you called to keep, you got 12. Nope, can't happen. Literally won't do it to you. It also maintains the order. So if you had the list of numbers from 1 to 10 and you only wanted to keep the even ones, it will give it back to you in 2, 4, 6, 8, 10. It won't give it to you jumbled up. I didn't list it here, but another thing about this too is that you're guaranteed that it keeps the same type. So if you call keep on a list of numbers, you're going to get a list of numbers back, not strings, not DTOs, not exceptions, right? Like you're guaranteed that. That's a lot of type and property guarantees you get for free for just using keep. So let's go derive this. Oh boy, good old delivery team. Man, and the audience is like, damn it, Cameron, I'm so tired of this. It's all good though. So we've looked at some of this code before, right? Of which delivery teams have more than 7 team members, right? And so we're going to go ahead and short circuit a lot of the deriving and go, sweet, we're going to write an extension method, call it get too big of teams. It's going to tie straight to the IEnumerable of delivery teams, thanks to Rob's suggestion. And it's going to for each over teams. And if the member count's greater than 7, we're going to do yield return team, right? So we're going to short circuit a lot of the logic we just did before, but this is what we've got. And so we pat ourselves on the back and go, good job. We wrote some good code. Let's go on. So then we get some other requirements to go, well, now we want to find which delivery teams have Dana as a team lead. So you go, all right, cool. Well, we'll write some more code. And it looks a lot like this. Still an extension method. We're still iterating through teams. And except this time we're checking on the team leads. And if one of them has Dana as team lead, we return that team. We being good developers, we take a look at our 2 extension methods and we go, uh-oh, man, these look familiar. In fact, maybe that's really the only difference so far. So what's a technique we would use here to refactor that out? Anybody want to take a guess?
Can we ask a question here too?
Yeah, absolutely.
Jeremy notes that we looked at IEnumerable. Does this also match iQueryable?
As long as iQueryable implements the IEnumerable interface, which it does, this would totally work. Now, that being said, you have to be really careful with iQueryable because what iQueryable will do for you under the hood is when you fire off certain LINQ expressions, it will try to convert it to SQL for you. And sometimes that's not going to go the way you'd hope. For example, if you try to call a .NET function that doesn't exist in SQL Server, it's going to brick. But that's actually more of a limitation of the iQueryable, more so than the IEnumerable portion. But a way to get around that is on the iQueryable, do a .to list. It sucks because that's going to bring it into memory. But at that point, it's also all objects. So now if your .NET code will play well with it. So, and there's a couple of other things you can do to work around that restriction, but that's a better question to expand upon at the end of the talk, not in the talk. But good question though, all the same.
Yeah, it's just a condition, right? So you could just pass a predicate instead.
Yeah, exactly. Right. You can totally refactor and use and pass in a func and pass in the predicate. So we'll do that. Right. So here we are. We've now changed the signature of get teams by. Now we've introduced this new thing. Takes a func of delivery team, turns back a Boolean, and we're just going to call that predicate right here. Yippee-ki-yay. Things are working. Now that we've got this new extension method called get teams by, we can refactor our other 2 methods. So the one that was called get teams that were too big, we now refactor it to use that get teams by. And same thing for get teams led by Dana. Not too bad. Code cleanup, burning some more code. Love it. But we can do a little bit better. So here's what we've got now for the get teams by. Is there any reason why we would need to limit this to just delivery teams? What's a technique we've seen tonight that allows you to parameterize on the type?
Generics.
Woohoo, generics indeed. So yeah, so the top is what we had before, the bottom's what we've got now. And if you're paying attention, you're like, wow, that looks really similar. In fact, the only differences are the types there. So we switched out for T source. So what's interesting now is that given this code, here's what where's implementation is in .NET. And boy, howdy, doesn't it look super familiar, right? Once again, the to list is one of their other performance optimizations, but otherwise logic is really the same. And once again, it kind of has to work this way. The only other way you could have implemented this code is if you had negated the predicate, like if you'd put the not in front of it. And if you recall, that's one of the big mistakes I hate with the word filter, because you don't know which way it's going to do the filtering, right? But the reason why we know these have to work is when we start genericizing code, there's less things you know about it, right? There's less things you know about the type. So you can't start creating something from nothing, right? Like if you just know you have a type of T source, you don't know if it has a constructor. You don't know how to construct one. You don't know what properties are even valid on it, right? So because of that, you're really kind of forced to implement it in really the only way you can, in such a way that the compiler works. And to me, this is the most fascinating part of LINQ, right? This idea that it has to work this way. And for those who've got a little bit of a functional programming, you'll know that's one of the big tenets, right? It's like, well, of course the code has to work that way. It's the only way it would type check. It's the only way it could work, which is pretty neat. Yeah, so at this point, you use keep data that you want. So at this point, let's take a pause and see if there's any questions in the chat. Barry, can you help me out a little bit?
Barry's muted, so I'll be his voice. I don't see any questions.
Wonderful. Barry's like, man, I did all this work for nothing, man. Cool.
I thought I'd hit the unmute button.
Hold down space harder, man. Just. So yeah, so you've seen select, you've seen where. Let's go to the trifecta. Let's hit the last one. Going from many to one using reduce. So if you're not familiar with reduce, imagine if you took like a couple eggs and reduced it down to an omelet, taking from many things down to one. So it's known as aggregate in LINQ, and to me, this is probably one of the most more difficult LINQ methods to get a hold of. But what aggregate will do / reduce is if you give it a collection, some initial value, and what they call a combiner function, you get back another value. So here is an implementation of an aggregate in action. So I have some initial value of 0. I've created this combining function that says, if you give me 2 integers, I'll return you back an integer known as addition. And then I'm going to generate a list of numbers from 1 to 10. And then I'm going to aggregate it by using the initial value of 0 and then combining it using the add function. So that's pretty much it at a high level, but you're probably like, Cameron, what's the actual practical applications of doing this? Because summing numbers is kind of rudimentary, or should I say elementary in that case. So speaking of elementary, let's start with some basic counting. So you get asked by payroll, hey, how many people do you have in the department nowadays? You're like, man, I don't know if I should answer that question in today's climate. But let's pretend you got asked that question anyway. So you go, all right, well, I'm going to write some code and we'll iterate through the teams and I'll set up a running total of 0, increment it by the member count, return back total. Not too bad. Okay, and you may have noticed I've short circuited this using extension methods, all that, just to kind of save that derivation. Well, let's say now that we've got this cool way of getting the number of employees, but now we want to get a formatted list of team names. So, okay, well, we got this string builder because we're going to be building up some strings. We say teams in the company, and then for every team, we're just going to pen line the team name and then returning back this whole string builder so it can be processed for whatever later down the road. Now, for those of you playing along at home, these two methods don't look like they actually have a whole lot in common, right? You can't genericize anything right now, right? Because ints and string builders have nothing in common. You ain't getting nothing out of that. But what if I told you there's a pattern here already? What if I told you both of these methods are using a very cookie cutter system? They both start with some initial value. They both have some combining logic. Well, the minute you have that, we can write reduce. So here's the implementation. And it's a nasty type signature, but we'll get through it, I promise. So the first thing that reduce is going to give you back, it's going to give you back some generic, some T result, right? And we had to start here because in the previous example, it could either return back an integer or a string builder Based on that, got to make it generic. So once we've got this T result, we now have to have some initial value that you have to tell us like, and a good way to think about the initial value is, what should I give you if the collection I'm working on is empty? That's a good way to think about it. So it made sense when we were summing up team members because the empty value was 0. And for the string builder, it was just that initial value of like, here's some team names that, and just like, here are the formatted team names. Once you've got this initial value though, this signature kind of derives itself where like, okay, well, I now need to have some function that says, given a T result and delivery team, return back another T result. But if you provide such a reducer, such a function, then I can do the following. I can set this T result, that's our initial value. I'm going to iterate through the teams. And then for each team, I'm going to call this reducer function and update result every time I go through that loop. And then once I'm done iterating through that loop, I will give you back the result. I should have called this out a little bit earlier, but something that you may have noticed is that unlike select and where that return you back IEnumerable stuff, this one doesn't. It gives you back a hard value. It has to, at least the way it's currently written. But what's cool is that now that we've got this kind of generic reduce running around, we can actually refactor our previous methods. So we had this total number of employees. So now we just got rid of the code I was doing before. We set the initial value in some func, right? And then we just call teams.reduce. And we can do a similar thing for the formatted team names, right? Initial value is that string builder. We provide a way to reduce it, and then we just call that reduce extension method. How are we doing so far?
There is a question.
Excellent.
The question Jay said, could we change delivery team to T? So can we genericize the delivery team?
Absolutely, we can. You are 2 slides ahead, my friend. Are there any more questions in the chat, Barry?
No, nothing else in there.
Wonderful. Yeah, so let's talk about that. You literally caught me a little bit ahead. Any reason why this should work on delivery team? Absolutely not. We can genericize that one more layer. And the fact that you all are already guessing my slide deck is telling me I'm doing probably a good job of hammering the generics pretty good. So yeah, so we've got reduce. So we just switched out delivery team for T source, and then all this has to work. And so this is our implementation of reduce. Here's Microsoft's version of Aggregate, which is their version. So if you ignore the if null checks, take a look at the T accumulate section, right? It holds on to some seed value, let's call it initial value, and then it iterates through the source, and then it calls this reducer func, and then it returns back the result. And it has to do it that way. Otherwise, none of the types would work out, right? It can't create values out of nothing because it doesn't know anything about the types except it's a T accumulate or a T source or a T whatever. How cool. And I didn't have to look at Microsoft Docs, man. We derived this by just following our nose, right? Like we're going to refactor this stuff. So
if only they had nullable reference types, they wouldn't need the throws right there at the beginning.
You had to bring it up, didn't you, Rob?
And Jeremy actually notes, I wonder how many people are having the, I know a few spots I can make this code better thoughts. And by this code, the current source code that needs to be refactored. That's awesome.
Nice, nice. Oh man, I can't wait to go back through the chat once it's all done and see all the puns. I'm literally living for the puns right now, right? That's why I'm excited about you all. You all raised the stakes. So hopefully it wasn't a mistake to miss out on them. So we're going to use reduce to transform a collection to a single value by first identifying the initial value and then writing some combining logic. So here comes the fun part. What if I told you this was all a lie? What if everything I showed you tonight was leading up to this one moment? What if I told you that you could rewrite all of LINQ using just reduce? What? No, seriously, we can totally go do this. Let me show you. So if you're going to use reduce, right, it's always 2 steps. What's the initial value, i.e. what should we return if there's no collection? And then, okay, assuming there is a collection, how do we combine elements? And you're like, Cameron, you're full of it. We can't do this. Like, Selecting where? They return back IEnumerables. You just told me to return back a single type. You lied, right? Well, not really. Let's take a look at these. So here is our definition of map, right? So for every sort, every item in the list, we're going to returning back that selector. So there's two questions we got to answer, right? What's the initial value, right? What should we return if the source is empty? So if you call map on an empty list, what would you get back? Anybody want to volunteer?
I'm guessing either null or an empty list.
Definitely don't want to do null because if you recall the properties of map, you never get back a null list. So it won't be null, but an empty list is right on the path. And so for those of you who may not know it, the
Tandy guesses empty list. So Tandy was right and I was wrong.
So fun fact, you can actually do enumerable of that t result.empty. So it's not even a list anymore, which is kind of fun. So this is your base value. This is what you return back if you don't have anything. So here comes the cool part to me. So because you know, so we've got this map via reduce. So you know what the signature has to be, right? It's got to extend on the IEnumerable of t source. It's got to have a func that goes from a selector. And you now know what the last line of this method has to be. It has to be return source.reduce. Here's the initial value and some reducer function that we've not defined yet. So I'm going to do control period to generate it, and I will get the following. If I can write some code that will type check, this will work. Okay. So this function says, all right, given an IEnumerable of t result and some t, you need to give me back an IEnumerable of t result. Whole bunch of technical stuff. Let's break it down. I need to do two steps. I need to first convert the item from the type of t to type of t result. And once I've done that, I now need to add or append that converted item to values. Okay. So let's take a look at converting from t to t result. So here's what we've got. And if you recall, the signature of map gives us a really handy function that knows how to go from t to t result. That's actually in the type signature. We're given that. So boom, step one, done. We've got a converted item. Now we've got to figure out a way to append it to a list, append it to the IEnumerable. Well, the way we can do that is literally call append. Now I cheated slightly here. The append method lives in the LINQ namespace, but here's what it's doing under the hood. It's doing a for each loop over everything in the list. And once that for each loop ends, it does yield return converted item. That's essentially append. I just didn't want to derive that for you on the fly, but pretend that we could have written that our own in like 2 lines or less. But guess what? You just rewrote map using only reduce. Okay. Let's keep going. So let's redo keep now. So if you recall, keep had this signature, right? It's going to go through a list of items, and if it matches some predicate, we return you back that item. So first question, what's the initial value? What should we return back if the source is empty? Pro tip, you've already seen this one time tonight already. Anybody want to take a guess?
Empty list.
Yeah, an empty list, that enumerable of t source now. And remember, it's t source because where keeps the type. If you have a list event, it gives you back a list event, not a list of string. So that's why it's t source here, but yeah. Cool. So now with that in mind, I get to do that same cool like code generation trick from before, where I can say, all right, source.reduce, here's your empty thing to start with. Here's the reducer, control period, generate it. Here's the signature. So once again, if I can write some code that can fit this signature, we're golden. Well, step one, we gotta check to see if the item meets the criteria. Step two, if it meets it, we gotta append it to values. So let's do that. What thing will we pass in that knows if this item fits some criteria or not? Possibly a predicate of sorts, if you will. Right? We've already got that. So that means I could write this type of code. So if that predicate's true for the item, I got to do something. And if it's not, I got to do something else. All right, if it matches, I do values.append item. And if it doesn't, I just give you back values. Ta-da. But you just rewrote keep using reduce. Yeah, go ahead, Barry.
Oh, nothing. I was just applauding.
Oh, applauding. Oh, man, you can tell I'm a noob in Zoom because I saw that. It's like, oh, man, he's going to ring me out and say, Cameron, you're wrong. Your entire approach is trash.
No, no, no. This is very impressive. Keep
I have a
going.
question though.
Yep, go for it.
Before we had yield return, which gave us deferred execution, and it didn't collect all the list using the memory just to hand it off.
Mm-hmm.
And we've kind of undone that part by switching to doing a reducer in both keep and where. Is there a way to keep the yield return in this mechanism?
So really quick, we did not get rid of the yield return. That values.append is a yield return, right? So when we do append, that's actually building up a new IEnumerable, which means you still have that delayed execution.
Oh, perfect. Problem solved.
Yeah, so that's still in here. Absolutely. Remember, all the properties of LINQ are still being held here. Otherwise, that's a big boo-boo. Great question, though. All right. Are there any other questions?
Zachary asks, when was yield return introduced? Would this be possible without that?
Would it be, let's think about it. So if you didn't have, oh goodness, you'd have to go back to see when the IEnumerable data type was introduced. So it's probably, if I had to take a guess, it was probably introduced the same time the extension methods came out. Like it was probably around that .C#3, C#4-ish type era. Here comes the cool part. If the IEnumerable data type didn't exist, you could still get away with a version of this on the list data type. The only nice thing about the IEnumerable data type and that interface is that it only has one method, and it's like the iterator. Like you have to implement its own version of an iterator. But once you have that iterator, for each loops work. And the minute you've got for each loops working, a lot of this other stuff works too. But I just don't know when the IEnumerable data type was introduced. I just don't have it off the top of my head. Sorry.
That makes sense. Another question from Michael. He asks, is this approach taken in the .NET framework?
Oh, absolutely not. No. No. And the big reason why is because if you take a look at the .NET framework, they do a lot of performance optimizations. They do a lot of type sniffing on the IEnumerable type. So they'll do things like, oh, if this is a list, I'm going to go process it this way. Not because it's the correct way, it's just a faster way, right? The approach that we took is it's a consistent approach that will always behave roughly the same no matter what the IEnumerable type is, which is great for learning this stuff. Please do not write your production code this way. However, that being said, if you take a look at a lot of other functional languages, Haskell comes to mind, Elm, you'll see that a lot of these type of operations are rewritten to just use reduce under the hood.
I'd like to clarify that a little bit if I can. Please. I mean, there's nothing wrong with doing things like Func and generics and all those things, all those pieces in your production code. The only part that you were saying the production code to be careful of was using this one piece to rebuild everything.
Oh, absolutely. Yeah. And here's my approach to stuff like this. The best way I learn LINQ is by the best way I learn these new advanced concepts is see how does the framework do it? What problems were they trying to solve? So all of this code I showed you tonight, you could literally pull down and clone and start running it locally. And it'll work, it'll behave, it'll do everything that you expect it to. It just may not be the most performant thing because I did not design it with performance in mind. And that's also not its goal, right? That being said, Barry's totally correct. Please use generics, please. Your future coworker will appreciate you for it. If you can leverage LINQ, please use it. Your future coworker will appreciate you for it. Extension methods, depends. Some people take it a little bit to an extreme, but I promise I will not look down upon you for using extension methods because I know I use them tremendously.
Jeremy has one more question. What do you think of LINQPad?
As somebody who has version 5 and 6 installed on his personal machine right now, I actually like it a lot. So I use LinkPad to do literally as a scratch pad of stuff, right? Like literally I do is like if I'm trying to write some code and I would want to experiment with how things work, I prefer using that over Visual Studio and VS Code, mostly because it's just a little bit more familiar to me. But nope, great tool, would highly recommend.
Perfect. That's all the questions we've got so far.
Cool. So wrapping up, let's put a bow on this then. So we covered a lot of stuff tonight, right? We covered a lot of concepts, and I'm going to be very upfront with you. Func's generics extension methods, that is not entry-level .NET experience. This is like mid-level at least, right? And I've worked with tons of senior devs who've never touched half this stuff. So we covered a lot of advanced stuff. However, we covered what is LINQ, right? You learned some of its applications. You learned some cool fundamentals in .NET, and you learned how to do your own version of map, keep, and reduce. And you found out that's actually not too far off from the way Microsoft does it. So if, I'm not going to lie, you may not have picked up 100% everything in the presentation, that's okay. If you only cover these next parts and keep it upstairs, then we're good. First of all, LINQ isn't magic. It's not some voodoo happening under the hood that you can't figure out. No, it's really not. It's kind of mathematics applied, really. And LINQ is nothing more but a composition of funcs, generics, and extension methods. And the reason why we want to do this is because we want to keep building bigger programs from smaller programs. And we have found by introducing all these concepts together, we can do that a little bit easier. So with that in mind, here are some resources and things that you might find helpful. Now, I'll be the first one to tell you, this slide is not always kept up to date with all the resources I find. My blog will be a much better place because as I find articles and posts and such, I'll update it. But the two I want to call out is JavaScript map, reduce, and filter, the JS array function explained with code examples is fantastic. It gives you a more pictorial representation of everything we talked about tonight, and all the concepts still hold, right? Instead of, since JavaScript can pass functions around willy-nilly, they don't need the func data type, right? If you saw extension methods and thought prototypical inheritance, you're not too far off. And then JavaScript's not typed, so you don't actually care about the generics, but if you go with TypeScript, then generics still work. So all that still applies. If you just want to take some of this code and play around with it, check out my GitHub repo, Level Up with LINQ. It's got all the code used here, and you'll actually find some other LINQ methods implemented using some of these techniques. So single or default, first or default, like those type of things. So yeah. That being said, I want to say thank you all so much for letting me present tonight. I had a blast, a lot of great questions in the chat. Hopefully you learned something new. If you all could do me a small favor, I'm always looking to improve, right? No one's perfect, and I know I'm not. So if you could take a moment, scan this QR code, and fill out the 1-question Google Doc survey and leave me some feedback, I definitely appreciate it. But otherwise, thank you all so very much. Had a blast.
Thank you. That was amazing.
That was so cool.
Yeah.
Many thank yous.
This was awesome.
Great presentation.
Thank you very much. Yeah.
Yep, thank you.
Hey, thank you.
Yeah.
Thank you.
I see the
Thank you.
link to this presentation is also posted in chat. That is awesome.
Oh man, I wonder, Justin James has already beat me to it. He's like, oh yeah, man, here's all this stuff. Wonderful. So the problem is I now have to scroll up to find all the puns. Oh goodness.
How do
We had one
capture
question
this?
about dot include. Can you tell us a bit more about dot include?
Dot include as in like the LINQ method dot include?
Yes.
I would have to take a look at it, but what's the question? Like, how would you implement in such a fashion, or?
The comment was, it feels like magic.
Give me 2 seconds here. Don't worry about me. I'm just going to see what that method is real quick and see if I can derive that on the fly.
Isn't that about SQL and ORMs in order to fetch specific fields from other tables?
It's from entity framework, yeah.
Nama, feel free to unmute yourself and add some clarification to your question or statement.
Well, Cameron's just saying it's not magic, but in my group, we always said that dot include feels like magic because yes, you can get all these different data fields with them.
Gotcha. So yeah, so I'm looking at the doc. So you're seeing someone like learn this on the fly real fast. So yeah, so dot include, that's going to be something that's not through LINQ itself. That's definitely an Unity framework thing. So the implementation though would like literally be like that. I could imagine it, especially if it's given that string, it's probably parsing that and updating the query under the hood, because what Unity framework's doing, pro tip, anything in Unity framework that you're using, it's literally just generating SQL under the hood and firing it off against your SQL Server database, right? So all that include, I say all that include is, my suspicion is that it's updating the query that's being generated to include those additional fields. And so whatever way it's implemented, you know, under the hood, that's something we'd have to look at in Unity framework. Does that kind of help? Maybe yes, no? Wonderful. For a minute, I thought it was like this super cool like LINQ method I should be using all over the place. I was like, oh man, include sounds awesome. And it's really, I was like, oh, it's in your framework. Okay, cool. That makes me feel a little bit better. Nice.
Michael Mann notes, the reveal at the end was quite impressive. Wasn't expecting it.
Oh, the let's rewrite it all and reduce. Yeah. Yeah. Well, I appreciate, man, I'm always so worried when I get to that section because it's like, well, if your mind hasn't melted down yet, let's go one step further.
Yeah, that was really, really sweet.
Yeah.
Yeah, it was.
Oh man, so I'm trying to go back into like Mixins. Hello, cute. Ah, there's the cutie joke. Nice. 4 Qs myself, cup of tea. Oh, jeez. Oof. Man, you all are punerific. Yeah. Cool. So yeah, did anybody else have any questions or feedback that we can chat about? Because you've all like, because I think you all wrap up 8 o'clock your all's time, I believe.
Yeah, give or take.
Give or take. Perfect.
Yeah. What's really cool coming up next month, we have Sarah Ford. She's going to talk to us about Git.
No, not next month. Sarah's
not next month.
After.
Sarah Ford is coming up eventually. Who's coming up next month?
So next month is Russ Festino talking about blockchain in C#. And then the month after that is Sarah Ford.
Ah, so come join us for Russ about blockchain. That'll be really, really fun. Provided he doesn't get hurricaned between now and then. He is in Florida.
Very disappointed. I had set that up, you know, probably the end of last year or early this year. And Russ is a great guy. And so we like to go out and hang out. And it's kind of disappointing that he has to do it remotely, but he's a great speaker. So it's going to be fun.
Yeah.
He's very energetic.
Yes. Mm-hmm.
Now, he was with
Xamarin
for a bit, right? And
he was, yeah, it was God, what did he do? I know he was a Microsoft developer evangelist for many years. And then he's hopped around and done a couple of things lately. But now he's working for a company that has their own blockchain and does some really amazing things with it. So, and they have a C# SDK, so it should be a lot of fun working with that.
Yeah, that will be fun.
What else was that? Oh yeah, Cameron.
Is he still doing the Southernmost user group?
No, I'm so crushed that that's gone away. For those who weren't familiar with that, that only happened like 3 times. The Southernmost user group happened in Key West, and we would go down there and we would do a a one-day conference right before the South Florida Code Camp. So we like fly down to Key West on Wednesday, do a conference on Thursday. Whoever was sober enough to talk would do the talk. And then on Friday, when we rolled out of bed, eventually we would caravan up to to Fort Lauderdale to do the South Florida Code Camp. So I miss those events a lot.
It sounds like you may have missed some of the ones you attended too.
It's funny, I have a good recovery time, or at least I did when I was a little younger. What was I going to point out? Oh yeah, so Cameron, you pointed out on one of your slides you had a text snippet from the Microsoft docs talking about the extension methods and from that extension method, so I actually did a major rewrite on that doc not
nice.
that long ago. Now that I just checked, I didn't touch that text. So that paragraph was in there already and I didn't touch that, but I did a bunch, including before I touched it, the guidance was avoid extension methods. And now the guidance doesn't say avoid it anymore.
Appreciate you doing that.
So that's also something everybody should, I don't work for Microsoft, but I could go in and update the Microsoft guidance on how to use extension methods and when to use it. So the docs are open source now. So of course they have to be approved, so what was it, Bill, oh God.
Was it Wagner?
Bill Wagner, yeah, was heavily involved in helping me do the edits, but, and he approved all the changes. But yeah, anybody can update guidance, update documentation, update samples and example code. So something to think about. If you find something in the docs that is not good enough, make it better. Beauty of open source.
Now I'm really curious, where can I bury RM-RF star?
In the predicate.
Rip to your hard drive, to anything of value you were doing, just rip. Oh, good times. Fun fact, when I had my first internship, I used to work at Oak Ridge National Labs. So if you're not familiar with their claim to fame, it's two. One is that's the place where the atomic bomb was built. And second is that they have the world's fastest supercomputer. So I used to work there doing stuff, and don't worry about that last part. And so I got handed like keys to production on a system, never worked in Linux before. And my boss gave me their profile, like here's some shortcuts and such. I just wanted to move a file. And instead I did not move a file. I tripped into one of their super secret shortcuts and deleted prod. Because what was source control? What was limited access? So I run the command, notice it takes a little bit longer, go to refresh the web app and go, huh, that's weird. Why is Rockhopper not responding? That's a bit unusual. And then I get a phone call from my boss and she's like, Cameron, did you do something interesting on that server? Nah, don't know what you're talking about. Maybe I may have ran this command. And that's how I burnt down prod in my first week. It's good times.
Nice.
Was that also your last
week? Everybody who's been around a long time has such a story. So,
no, that was not my last week. What that happened, Rob, is I lost my prod rights immediately, and they learned the lesson about putting up guardrails of such a thing.
And mental note: don't alias RM-RF star.
Please tell me you didn't alias.
Oh, no. This was a user profile that my boss, because I said didn't have much Linux experience. And they're like, oh yeah, here, use this. This will kind of help solidify things. So I was following a forum because I was wanting to rename a file. Yeah. Now you understand the problem.
Okay. Oh, yikes.
I just did what it told me to do. Why? How could this possibly have gone wrong? Rip.
Yeah. The only thing I did. I have a fun prod story about changing data types on a MySQL table from blob to text, since only text was in the blob, but it was Word 2003 text. Yeah. It was
So
like,
how
oh,
long,
okay.
how
Oh,
long did it
this-
take for you to realize? How long did it take
Well-
for you to realize something went wrong?
Yeah, so as I was looking at the website, the newer the newer things that were pasted in records were fine. I'm like, okay, let's go back a little older. It was then I saw the nice little hi garble. I'm like, going down a list, my mouth is just dropped. And as this is happening, my boss at the time just happened to walk by. It's like, hey, how's it going? You all right? I'm like, I think I messed up. Needless to say, that was a good thing we found the backup. Because it was, I think it was an external, external site just out of our, normal sites, hosted on GoDaddy. And it was just like an hour before that backup was override.
Jeez.
So it was like, oh, I could have completely, ultimately screwed stuff up. So yeah.
But you know what though? They learned their lesson. They would have learned their lesson. Like, you know what? maybe we should put a little bit more guardrails on here. Maybe we should think some of our strategies.
What's really funny is when you get to the end of that story and they go, backup? What do you mean by that?
Jeez.
Oh, what was that? So Rob Connery, I think it was Rob Connery, wrote a book that ostensibly teaches Postgres, but he does it using, like with prose and actually a storyline. And the very first chapter of the book is how basically an intern ended up being the DBA for a project where they're basically launching a rover to some moon of Jupiter or something like that. It was a very interesting setup that they had to go through, where basically production got completely destroyed. Lot to it, lot happened. I will find the name of the book now. Yes. It is called A Curious Moon. The moon is like in Celeb. It is
Try
a
it
moon
again.
of Saturn.
It's like, try it again. I've been there before.
Yeah.
Where you're like,
Enceladus, Enceladus, and it's about the Cassini, and it's data from the Cassini probe that got completely wiped out.
And Claudius? I'm just guessing at pronunciation.
Oh, maybe. And no, I don't know. But anyways, really good book. If you want to learn SQL and you want to learn Postgres, that's a good way to do it.
That sounds cool. And learning it in the context of a story sounds like a really, really cool way to do it.
Yep. Yeah, it's well done.
I recall them interviewing him on .NET Rocks at the time.
Yeah, they love having him on .NET Rocks. He's a good interview.
Yeah. I see a lot of people checking out to go grab dinner, and I think I need to go do the same. This was a lot of fun, though.
Yep. Thanks for coming, everyone. Next month is technically Southeast Valley, so it's on Thursday, September 24th.
Yep.
Awesome. Thanks, everyone.
All right. Take it easy.
Thanks, everybody.
Right.
Good night.